Welcome to DevOps Accents, a podcast on everything around DevOps, public cloud, and cloud-native topics, with your hosts, Pablo, Leo, and Kirill.
Hello and welcome into another episode of DevOps Accents, the podcast where we, the co-founders of MKDev, get together to discuss all things around DevOps, cloud-native technologies, artificial intelligence, everything that get into our attention. At MKDev, we provide cloud-native services, consultancy, and engineering services to you, your company, your infrastructure, and your artificial intelligence initiatives. If you are first time on the podcast, here we invite various guests from different domains to discuss how the industry is going, what's new, what needs to be considered especially with your next steps and with your next projects, how to react to them, and basically anything that get into in our attention. Best way to not to miss anything is to be subscribed to our MKDev Dispatch newsletter, where we every 2 weeks share what's happened, what's new, our new articles, new videos, and of course this podcast. Make sure to be subscribed, link in the description. And last time, a few weeks ago, if you remember, we were discussing artificial intelligence and European AI Act with our head of data and AI, Paul Larson. Link in the description. And we touched a little bit on vibe coding there. What is that and how we should probably, react to this new paradigm. And I decided that we need to explore this idea a little bit more. And for that, I invited today as my guest, Tammuz Dubnov, founder and Chief Technology Officer at AutonomyAI. Tammuz has spent 10 years turning machine learning ideas into production system, and he has over a decade of experience leading startups in machine and deep learning across text, vision, and vector domains. And this April, his team raised more than 4 million in pre-seed funding to launch their own agentic context engine. This is something we are going to discuss today. This is ACE, an autonomous coding agent. We'll unpack later in this episode. Thanks for coming, Tammuz. How are you?
I'm doing well. Thank you so much for inviting me. Very happy to be here.
Yeah, absolutely. Thank you for coming. Tammuz, giving the name of our podcast, DevOps Accents, how do you think you fit into this industry, and what is your accent here?
Sure. So kind of broader kind of operations of dev in general is being completely kind of reimagined with Gen AI. And everything we're going to talk about vibe engineering, vibe coding, and how yesterday's development practices are not today's practices and not tomorrow's. And I think that's kind of the accent that we bring in. We're focused very much on agents and how they come into play and how they kind of reshape and reimagine what the R&D workflow is for a developer, is for the whole R&D unit as a whole, how it touches on a few different personas, and how if before there was kind of unsaid alignment across the tasks, both from leadership to product to developers, how that's changing now with agents and AI that takes you really literally, and you have to be really precise in how you use it and when you use it.
Were you thinking about this idea, this company idea, before the term appeared, and the way the agents and large language models, because given your extensive experience and your background in machine learning, can you give us a brief overview how it started and how you end up where you currently are, giving your journey? Did you have to make a shift, or 90 degrees turn in the process because of large language models emerged 2 years ago?
So actually, I wasn't working in a startup actively during that time, but as soon as LLMs came out, I was interested in the point it really was a pain point for me in the past. As kind of a founder and CTO for multiple startups now, you are very much hands-on in the code for the first bit of lifetime for the startup. As soon as your team scales, you lose touch. And as someone from like a very strong development background myself, I was always kind of frustrated when there was that gap and that buffer. And I know the code base was evolving. I didn't know if it was evolving quite like I intended, or if all the different personas and all different developers working on it kind of pulled it in different directions from what I meant. And that was the first place where LLMs like captured me. I was like, okay, well, now that there's an LLM, I can have it always monitor the code base and tell me kind of abstractly what's going on, what area is changing, how it's changing, and in that way shrink that gap for me. So as a CTO, I could be much more on like the code base. Even as our team is now 17 people. I can't review all the PRs. There's huge chunks of the code base that I'm no longer familiar with intimately. But using LLMs, I can bridge that and I can know what's going on. So that's where this started. It was a question of me and myself, kind of how can I model a code base so that an LLM can understand it and then communicate it to me as kind of CTO so I can keep track. And within that question, very early on, we started working on agents a year and a half ago, before it was really a term, before it was mainstream, before anybody was really interested in it all the way. And that was based on this kind of modeling approach. We were modeling a code base so that an LLM can understand it. And then initially we wanted to say, okay, well, in this function, kind of do this. But then there's so many variations. We found out it was much better to ask it what we should do and then have it also execute, which is effectively an agent. So it kind of led us, modeling code base led us to agents way before agents were agents. And from there, we realized that very soon, the way the world is going is you don't want to orient the task just for humans. Now you want to orient the task for agents. And of course, the agents are working code bases. You need them to understand the code base, keep track, understand everything that came in. ACE, like you mentioned, our agentic context engine is built on top of a few pillars. One of them is the code base, models everything. Every time anything changes, it has a hashed representation of the entire code base. It can tell instantly what changed, where it changed, what the impacts are. Kind of everything I wish I could do if I had all the time in the world to just look at the code.
Yeah, I completely understand. We will discuss this extensively a little bit later. Now I'm more interested into your startup journey in this industry. Do you feel pressure? Because so many companies now, AI companies, AI startups, and as you mentioned, you started this a year and a half ago. I can guarantee many more companies, many more people, they were at the same page at the same time. Is there, I don't know, like a rush to hurry up because if you don't do this, someone else will do that. And how is that for you from entrepreneur perspective? Do you feel this pressure?
So the expectations went over the roof. The expectations are true for VP kind of engineers in general. All companies, small and big, are expected to speed up really dramatically in terms of R&D speed. But now for a startup that's fighting kind of an existential fight to exist and survive, we have to go even faster. So it's definitely it's not a marathon. It's just like a really, really long sprint. Bunch of sprints in a row with no break. But that's the game. We're really happy. It's really fascinating. It's been interesting because we can build stuff faster and faster, of course, because of LLMs and how we use it internally and how we're structuring our company internally to speed up our dev velocity. With that, we've had a few hiccups. I don't know if hiccups is the right word, but we built something, got it working really well, and then a model upgraded, and suddenly like this huge amount of work we did to overcome the previous model's limitation. Well, this LM no longer has that limitation, so all that work no longer needs to happen. So that happened a few times. And we're really impressed with ourselves, so we could get kind of the weaker model to do this amazing thing. Well, now there's no more weak model, so it's been easier. So in that sense, it's also scary because it means somebody coming into the race now didn't have to face those challenges that no longer exist that we had to, that slowed us down. So in short, yes, definitely feel that push.
Because it's not like you have to invent something new, but you rely on a technology that evolves so quickly, rapidly, and tomorrow they will release, I don't know, GPT-5, and then okay, we have to redo everything that we built to this day.
We got better at that, actually. We have some techniques now. Like every time we work on an agent or any substep within an agentic flow, we already validate that it works across all the strong models of today, and make sure that our prompts are, we call it LLM interactions, that they're robust enough to always manage with better or different models and never be overfitted to a model. But beyond that, we also kind of flag if there's within an agentic flow something we're overcoming now, we do flag it so that we're aware in the future to test every new model that comes out if we can skip that challenge.
Okay, let's give our listeners a little bit more context what we are actually discussing here. So we are talking more about so named vibe coding, a term that was invented or let's say popularized probably by Andrei Karpathy on this February. So this is like 2 months old term, but everybody is using it already. And what it does, it basically encourages developers to describe desired outcomes in plain human language and let an LLM write the code. And so the marketing sizzle around vibe coding reminds me of when continuous deployment first hit the enterprise, like a leap in speed followed by headline-grabbing outages. So a quick story. I've read a number of articles and opinions on that. So let's take one, for example, a mid-sized e-commerce shop gave their agent a one-line prompt: launch a flash sale banners when inventory drops below 5%. Simple enough, right? So not a big deal. The agent produces working code in under an hour, shipped production the next morning, and sales spiked. It works just fine. But 2 weeks later, finance flagged a revenue gap. The banner logic miscounted reserve stocks. So high margin items were discounted prematurely, and the regression slipped through test because quality assurance mocked a clean inventory feed. So this anecdote crystallizes 3 fears I keep hearing and 3 basic the way how people understand vibe coding. Okay, so this is auto-generated code that passes the happy phase, and yet it hides some corner case wrote in there that nobody notices. And another one, junior devs, they trust the agent's sophistication, and they might skip deep review. And the third one, probably the most interesting, is every bug becomes a training data. So potentially poisoning the next generation of models and creating a spiral of garbage in, garbage out. So how real is that spiral? Are we at risk of turning the open source corpus into an ever noisier data set, or will, I know how to put it, retrieval-based training automatically flavor higher quality code and how it understands if this code is higher quality? But I put it differently. Are we speeding towards a self-reinforcing regression loop, or is it that fear is overblown?
So I think fear is overblown because of agents. We're an agent company, so we rethink everything around that, and I'll explain shortly. But just a fun story, and kind of interesting that you mentioned that the CI/CD at first. we first started kind of vibe coding, I think 7 or 8 months ago, when our senior developer that was actually just setting up our CI/CD started showing off. I did the whole thing. I didn't write any code. I was just chatting with the LLM, and he got it end to end. And that's kind of the way that the vibe coding can be done safely. If you have someone super senior that is using it, and there he's writing configs that were really time consuming, but LLM saw enough of them that he was able to rush through it much faster. Something that should have taken them, I don't know, 3 weeks, he did in like 3 days. But he has that seniority level to look at the output, know when something's wrong, and give the exact feedback on, no, that's not what I meant. I want you to do this. And that's exactly where vibe coding is falling now. You have non-seniors, or let's say lazy seniors, not in a bad way, just because of the speed expectations today, that aren't doing that kind of validation, the in-depth validation, and the feedback saying, oh, that's not what I meant. I see you did that logic this way. No, that's not what I was going for. I was going for this. So without that really strong human in the loop feedback cycle, and like we said, the models got better. So now suddenly they're able to do something end to end, like you mentioned with the banners, and you see the results, and they look so good on the surface that you're not going deeper in the code and saying, wait, the logic there is not how I meant for it, or it's not going to be sustainable over time. That's exactly the danger. And if you look at the increased use in AI dev tools, well, there's increased. I think it's about 40% increase in bug rate and about 40% increase in code churn. Okay, so it's great. They're writing code, you're going really fast. Well, 40% of that code is you're just going to throw away. It's churn. It means that as soon as you get to an issue, you look at the code and you're like, oh, I didn't need most of this. Bugs increase dramatically, so they hide bugs everywhere. And then exactly what you said, the downwards implication is, well, LLMs are being retrained all the time. So they're becoming better and better, but they're learning on open source projects, and people are vibe coding those open source, and therefore kind of producing low quality code. But in honesty, we saw that issue like from the LLMs from the start. If you look at the distribution of high quality to low quality code in open source, it's pretty poor already. Most of it is not great. Some of it is amazing, but it's not true just for open source. Like we're seeing it, our agents work in code bases for huge organizations, and a part of the struggle that we face is, okay, well, some of those organizations have areas of the code that are really poorly written, and some areas that are really great. And it goes back to kind of the developers in the organization. Some are amazing, some are let's say less polished on their work, and we need to deal with all of it. At least our agents do. And the beauty with LLMs that learn on everything is that if you point them correctly, they can give you that 1% golden code output. So now it becomes more of I'd say knowledge gap on how to use LLM to give you high quality code. Because if you tell it, okay, give me code that does this, it will take more or less the center of all the quality code it's seen, and it'll give you something mid or low quality, because that's the average. So the burden falls on the developers to learn how to interact with LLMs in a way that gives them that polished 1% of code that the LLM saw, and not that other 90% that you don't actually want in terms of code quality.
Yeah, I understand. But let's give more, I'd say, more clear example how it should work in ideal world. Because what we are looking for here, because okay, I've been reading on X a few funny stories how people see the developers work. So the developer he sits at the desktop, and they have number of Windows tabs opened. One tab is ChatGPT, another one is Cloud, Gemini 2.5 Pro, and another one. Okay, so you name it, and every model receives the same prompt, which and then he basically copy pastes this Python script that the model generated, put it into run it, and which works better, he goes with this result. This is how people basically understand vibe coding, right? But how it works in reality, how it should work, and what people can expect if they use a tool like AutonomyAI that you create. There are clearly misconceptions. Help us understand it better how it should work.
So you beautifully you described vibe coding. And we're, as a company, we're trying to push everybody to do vibe engineering, as we call it, which means there's kind of a big gap between, let's say, someone just finished their computer science degree and they're starting their first job as a developer. They can write code, but it's very different from someone who's a senior who's been there for 15 years, who's a real software engineer. And we're very explicitly using the word engineer. Good maintainable code is not just code that runs. It's code that's modular, that is consistently dry, kind of don't repeat yourself, reuse these components. If I want to change something tomorrow, it's really easy to change that thing, propagate accordingly. And it's not spaghetti code that I'm going to spend, a small change is going to take me days to test to make sure it didn't break anything. And there's best practices for that, right? Testing is kind of an obvious one. But if you when you're vibe coding, or we're trying to push it more to vibe engineering, if you're saying don't write the code first, we're going to figure out the test cases. Let's write all the test cases. We're going more for test-driven development. So my vibe engineering workflow is, okay, we're going to talk about the testing. We're going to define all the test cases. Now we have code for that. Now let's go ahead and implement it. And in that way, when you do the work, also make a script that runs all the tests that we built. And in the future, when I'm asking you to change more and more things as an LLM, and you're going to touch so many things, some that I meant for you to touch, some that I didn't mean for you to touch, well, that test is always going to run. And I'm always, of course, going to be adding more tests as I go. And I'll have a way to make it less prone to regressions. Right? As an LLM touches something I didn't mean to, at least the tests will catch it. We're just talking about one part of it. There's more to vibe engineering, but that's at least one part of it, where you can have consistent results and have it be more resistant to regressions.
I see. Okay, but I still have questions. For example, I can imagine two, let's say, edge cases, and let's contrast two prompts. For example, one, even if I am an experienced engineer and I know precisely what I need from my code and from my product, and I say generate Next.js page that shows, okay, let's for example, we are working on a health device or something like that, and one prompt for me is generate a Next.js page that shows heart rate zones with a start and stop button, for example, because I understand what I want from that. Another example would be, I am training for a marathon, and during intervals, I want real-time zone feedback or post-workout recovery stats on my body, and a way to share progress with, for example, my coach, my peers, and I need data privacy. That's another prompt. And prompt B, for me, it seeds a product narrative, outcomes, constraints, stakeholders. Prompt A, on the other hand, it yields runnable code. So my hunch is that sustainable engineering emerges when we embed product context into the prompt, right? And from what you've seen so far, like, how do successful teams write their code? Do they still write traditional design documents, or do you want them to do that? Or should they have or maybe they have merged that intent into outcome first prompts and let the agent trace implementation details? Where is this line between storytelling and spec writing in this new world, how you imagine it?
Okay. First of all, beautiful question. That's exactly kind of the gap that the people are falling at. let's take scenario A. So in that first prompt, you're just saying create the code. Here's the ticket scope, if we can name it that. And there's a lot of stuff that you didn't include in that scope, right? Because you know how you're going to implement it, but for the LM to do a great job, there's a bunch of the set, like
basically LLM works in vacuum. So
and you have a bunch of stuff that you're not mentioning because it's obvious to you, and you don't even realize that you need to mention because it's so obvious to you, but the LM doesn't know it. So when it does the work, it'll do kind of some variations of the work, but not exactly what you meant. The right way to do that, for example, is not, okay, here it is, do the code. It's, here it is. Let's consider all the edge cases that I didn't define here, and let's work on creating a better scope ticket together. And then you do that interaction with the LLM. In the end, you get that the ticket, or not the ticket, frankly, the context that the LM has to look at when it actually goes to do the task is much richer. Because you do a few interactions, it tells you the edge cases it can think of. You mentioned edge cases you can think of. You explain the behavior you wanted to take here and here. And only then, when you have kind of a pretty serious context, do you tell it, now do the code. And then it can finally understand all those hidden elements that were maybe obvious to you, but not obvious to it. And that ties beautifully into kind of the prompt B that you mentioned. Well, there you're saying, this is the behavior I want from product level. And that automatically answers a lot of those questions that were unknown in prompt A. So by giving it the product level perspective on the task that you're trying to do, it can have a much better time kind of guessing behavior at edge case that it runs into and implements in the code, understanding what you actually meant. And that's something that we're addressing as a company by working on agents right now that face products, not just developers. So we're saying, okay, as a product, hey, you're going to give a ticket that's eventually going to go to a developer and maybe along the way to an AI agent. In our case, we want to always go through an AI agent. But how can we make sure that that ticket is scoped, detailed enough that when a human reads it, it's fine. The human has a bunch of knowledge and a bunch of context and can make those logical jumps where something's not mentioned. But the AI agent, the LLM, when it reads it, it doesn't have that context. Not necessarily, at least. And you don't want it to be guessing stuff that you know how you want it to behave. So that's where the gap is. And that's why B works so much better.
Do you think your project infrastructure is well set and maintained? We know for sure there is always room for improvement. If you are uncertain where to begin, let's first do an audit of what you already have. We will review your setup from every angle: performance, cost, security, high availability, and automation, and provide you with a detailed roadmap of which direction your infrastructure should go, generate concrete tasks for you to implement, or even take on your infra entirely, if you let us, of course.
All right, but who is the person who, because when it comes to product design, we have product designers and then we have developers. Who is this person who should start working with agent? Because what would be the best practice? Describe goals and then accept that the agent picks the tools. And this is where basically, I don't know, maybe product designers' jobs is done, and then it forwards it to the developers, and then the developers, they will debate the choices that the agent made. Or should teams still prescribe architecture upfront before the product designers start communicating with an agent?
So our approach is, when the product designer is communicating with the agent, we use ACE. So we give the agent context for how the code base actually works, so it can use that knowledge when it's interacting with the product and create the alignment. If you don't have that, then I would want the product to just create a really in-scope description of the product features and the user behavior they expect. And then when it gets to the actual developer who's about to, let's say, vibe code or vibe engineer, just an important precursor is not take this, implement it, but first take this, let's plan out the architecture together. Okay, me and the LM, we're aligned in the architecture. Now do the work. So just that small pre-step of don't write code right away, let's make sure we're aligned, is actually really critical.
And do we have to, I'd say a lot of people are going to work there. And your company coined vibe engineering. Agents stay aligned with organization's infrastructure and context. We should feed what's happening, what the ideas, business goals to populate the context. And what does it look like day to day? Do you have to maintain a context file or preference stacks? And like, are those prompts verbose manifestos? So confirm or disapprove. The less we specify how, the better agents leverage hidden opportunities, but only if the agent is steeped in organizational context.
So the way we work is the ACE that we mentioned, the Agentic Context Engine, has a knowledge base that it builds over time. Kind of the obvious one that we share is one of them is it takes your code base and it annotates your code base. In its knowledge base. So it knows what's where, it knows what to look for. If it's looking for behavior X, it knows to look at this folder and maybe this file and maybe even this function, depends how it annotated. But that's all stuff that we leave in the knowledge base for ACE, and it's something that the agent maintains on its own. That's what we mentioned hashing in it previously, but it has a way to store the state of the code. If something changes, it knows exactly that something changed and it updates. It literally rereads those files if something changed and creates a new knowledge base. And in that sense, we're preventing you from having to give us all those details. Meaning, I don't even, an obvious example, we're in the front end side first. That's where we decided we're going to create autonomous front end as our first kind of milestone as a company. We don't need you to tell us almost anything. The way the workflow for front end works today, in most organization, a designer or product decides what he wants the behavior to be. It goes to the designer creates the Figma design, and honestly, that's all we need. The interface today is literally give us a Figma URL. We go there. We have an ACE running on Figma as well that gets all the data from Figma that it needs to understand the design nuances. ACE on the code base goes and finds like the UI kit, for example. An organization defines a UI kit in a package JSON. You as a developer, if you do vibe coding in a kind of a traditional sense, the right way to do it is to constantly say, okay, we're using this library, go and implement it with this library. This is all stuff that our agent just picks up on their own. As they do the work, they look at the package JSON if they need to decide what libraries are important. They look at all your component files, they decide what components are appropriate. They do a lot of this work just completely transparently. They even align with the way your coding standards is and how you like to write. For us, they even create mock data so that they can render it. They find your run command, they render, they see if it looks like it to Figma, they do iterations to resolve it and improve it. So all this stuff and this ongoing knowledge and how to work with the code, how to contribute to the code, what parts of the code to reuse, the agent maintains on its own and uses as it needs to.
I now that you described this, I'm sitting here and I'm thinking, every time the model picks one tool over another, how do you make it work in this specific way? Do you train them to understand which works better in a particular circumstances, or does it just basically take data about this tool and use cases from open data, from Reddit, from user comments, Stack Overflow, things like that, and he understand, okay, this should work in this specific case because, for example, I work with Figma a lot extensively, and I know that certain plugins don't. There is no all fits them all tool, and I just wonder, how do you train them, or do you rely on the pre-existed training data? And maybe there is, I don't know, there is a mechanism that lets your team to disagree constructively with the agent's decision, like something enabling a quick, why did you pick that integration, or is it traditional code review all over again?
Okay, so a few parts to that answer. First, we're outside of the model training business. We just decided that there's too many huge players throwing amazing resources and huge amounts of capital on it. So
Okay, understandable.
focus on the application layer. How can we use those LLMs to succeed at our task to the best extent possible? So in that sense, we don't have the privilege to train the model to understand this tool or that tool. But we do model the code base so deeply that often the answers are there. So if you had a developer that was going to do task A and they had all the time in the world, they would basically look through the entire code base, see if there's something similar to task A that they were going to do, get inspiration from that, and then do task A in a way that matches how the code base is written. So by thinking in that way, we enable the agent to scour your code base, find all the examples, look literally through every component, see if that component has the exact variant that it needs to for this screen, or if the right move is to create a new component for this screen, or if the right move is to take that component and enlarge it a little bit to also support this case. But by looking through your code base, you get a lot of the answers. We do have some tools where it can search the web if it needs special documentations on some library, because it's not a local component, but it's a library you're using, and there's some, let's say, library version to it that there's misalignment. But the beauty is we also built it so that there's a feedback loop and a learning curve over time. So as the agent does its work, and we said it validates. Okay, so for example, as it validates, it renders, but it got a compilation error. So then it goes on a loop of fixing compilation errors until it gets to the rendered results it wanted to. Well, every time it fixes a compilation error, in effect, it's like it's learning your code base better and how it should behave within your code base. So it adds it to the knowledge base. So next time, as it implements, it can look at how it, kind of the knowledge base and the cheat sheet it created, and how you like to write and how it can write in a way that matches your code base and actually works with it. Does that make sense?
Yeah, that makes sense. But then you have to create so many layers on top to push your engine into the right direction of thinking, modeling. And does it lose context on the way? Okay, so because I know there are some constraints with large language modules. You can only put so much data into it for it to produce your data, but you have to remember about your business outcomes, your contacts, project, products, your user data, who they are. It's so many things to remember, but I can imagine that at some point. A model will start producing results basing on its rehearsed previous outputs rather than relying on the data that you fed to it earlier. At least this is something that happened to me when I tried to work, for example, with custom GPT, right? So I upload documents about my company, things like that, that I wanted from it, and I start discussing with it. Then at some point, it completely forgets all the data that I fed and start discussing. And I have to make it to remember, okay, go and check these files again before producing this new result. And from time to time, I realize that I have to restart the conversation from scratch to, okay, you have to sort of get back to normal, start acting normal. Do you experience that? Do you have some guardrails or things like that to prevent that for on the user's end?
Yeah, so that it's a fine line. It's a fine line between context that is helpful to context that is noise. And as soon as context is noise, then of course the task derails. The way we did it is we took a really in-depth look at the workflow of R&D teams across different tasks. So let's say just a basic example is, let's say a new design. Okay, let's take that use case. So you have a Figma for a brand new page you never had in your code base before, and you need to add it. So that's a very reoccurring workflow. So we modeled that workflow. We understood the exact steps that a front-end developer would do if they were going to do that task and do it as professionally as possible. And for each step, we built our own custom context. So the context doesn't actually just carry over, increase as you go through the task. Each sub-step has its own unique context that we manage. And if not, then we let the LLM manage the context before going to the next step. And in that way, it never grows beyond a certain capacity, but it also never turns to noise. It's always context relevant. And I guess you could do it yourself. It's just a lot of work. But if if you thought it through and you're like, okay, well, actually, I'm asking you to do these 4 steps. Each one of the steps I'm going to make is a brand new, fresh chat, and I'm going to copy over just the context I need for that. Then you'd have no issue. But that's exactly the step where it's kind of an agentic workflow and not an ongoing chat experience.
But from the user's perspective, do you think a person who is working with this engine, with ACE, they have to understand how it works to work more effectively with? Because I can imagine like a normal person who, okay, so this is magic. I just tell it what I want and it produces me a result. But do you need to put someone who actually understand, and do you let the user actually understand how your engine works in order to get a better result from better to set the expectations right and to expect a better result with your engine?
Sure. So our goal is for the agent interface to be so simple and that a non-developer could use it eventually. Right now we're developer focused, but it is frankly within 4 clicks. First click is give me the Figma. Second click is from the Figma screen, what part do you want me to work on? Third click is, okay, approve the components I'm going to use. Here, I'm going to show it to you. And fourth click is, I'm done. Thank you so much for the code. Like that. That's it. Like 4 clicks, minutes, and work of sometimes days is done in minutes. But for us, we did add kind of psychological explanations to it that we don't really need from the agentic flow. The way it comes into play today is the components. So when you're doing front-end work, a big question mark is, I'm going to implement this page. Well, I have these 200 components. Which components am I going to reuse to create this page? And our agent obviously goes through those 200 components and chooses really quite well. But we made a dedicated interface where it shows you, first of all, it takes the screen and breaks it up to sub parts of the screen. So you can understand kind of, okay, well, for this part where there's like a header, I plan to use this components. And for this part where there's like this text body, I'm going to use this components. And other than putting the component name, it even has a little hover where if you hover, it explains why. So I was just on a client call this morning, and the user there, like it showed 2 components that it was going to use for something. It has the option to show you a component that it thinks is likely, but then also show you a component and choose to use it. That's kind of the way it's built. So that way, if it makes a mistake, you can just reselect. But there, it was beautiful. It showed 2 components that it thought were relevant, and it shows one. And when you hover on the explanation, it says, okay, well, this bottom component is used by that top component, and the top component is used more often than that bottom component. And while they can both be applicable for this task, I'm going to use the more popular component because that's what I see is prevalent in the code base, and that's what I think is more correct to use. And it just, the explanation was spot on. It even gave you the number of times it saw it used. So that's part where the psychological alignment happens, because you also build trust, and also you as a developer, you don't always know the right answer. Codebase is massive. 20 people touched it. It changed since 2 days ago when you were trying to be up to date. So it's also a really great way for you as a developer to learn better if this is the right way or not, by looking how the agent thought about it.
I have a pretty clear vision now what kind of teams might need this tool. Agree or disagree? So this is a smaller companies, probably at this stage at least, with a limited number of developers, and they can, at this stage they can have only 1 or 2 senior developers who will maintain the code, the project, and understand the result, and everybody else can be either juniors or maybe even product designers who will be using this engine to generate, to push ideas, push features into production more quickly and effectively. Is this the way how you envision the user base of your project? Or do you aim into something more enterprise scale, into more technology heavy, data heavy teams.
So it's interesting you say that. A lot of our early kind of customers and organizations are smaller because it's just so important for them to move so fast that they're super eager. But we also have some huge organizations use us. And for them, the problem is the same or even worse. If we can talk about kind of the code base health for a large organization, it's not amazing. It's actually much worse than we expected when we started this journey. And we've been shocked to see how bad it is in areas. But if you're a huge organization with, let's say, hundreds of developers, and you have hundreds of people touching the code base, and there's no way that they're in sync with what each other one is doing, and that way it means that the whole dry kind of don't repeat yourself. What you would want as a shining, it's not happening, because there's a lot of duplications happening already. Parts of the code base are better, some are worse. We even define this as kind of architecture hygiene. So like we're very explicitly saying, listen, we're going to do the product facing work, but we're also going to do architecture hygiene, whether you ask us to or not, because parts of your code base need work so that we can have a better time reusing them. So for huge organizations, it adds a lot. It really makes sense of everything. It integrates with their existing workflows really well. And within, I said 200 developers, for example, there's a huge distribution of developer quality. Well, if they use us, everybody's top notch. The code is standardized. The junior that came yesterday is producing code at the quality of the senior that's been here for 3 years.
Mm-hmm. I think this is a good time for me to remind those who listen to us that at MKDev, we provide services that help you build your AI strategy inside your organization. If you're just starting this journey, we can help you understand better how it works, no matter how small or big your company is. And I have so many questions to you, but I realize that we don't have much more time for that. But given the previous answer, I immediately have questions on how do we onboard new hires, for example, 3 years later with everything that we have now. Do they read the original prompt history or to understand the past job, or do we still need human curated architecture documentation to make this onboarding? Or is it too early to discuss this because we need to better understand how the companies actually use these tools?
So two parts. First, just an interesting story. There was one company that used us, or they still use us, and the team lead reached out like the next day, like ecstatic, that a new developer that just started yesterday already did the work, picked the right components because the agent picked the right components, and the code quality output was amazing. So what this means is effectively like you can skip onboarding because the agent has all that kind of tribal knowledge and which components exist and how does the code base behave. All that knowledge exists within the ACE and the agent, and therefore, in theory and for us in practice, we see that the human developer doesn't have to do that onboarding; they can just jump straight into the task. And so that's one part. It's really interesting that the whole onboarding experience for developers is changing, and I think drastically changing. And then the second part of your question is, do we curate some kind of list of prompts or stuff like that so they can see the history? Well, at Codebase, you sort of have that, right? You have doc strings, you have documentation. Initially, we had an agent, or one of the goals was add documentations everywhere. We almost no longer believe in it. Now we have a different agent called the visualizer that for any questions or any code snippet or any file or any directory, whatever setup you want, you just do kind of right-click explain. It looks through the code. It decides what's interesting to explain about the code, and then it makes a few explanations with diagrams. So it makes like a sequence diagram, a flow diagram, whatever it thinks is right to communicate the point. You can, of course, ask follow-up questions, but it does this in real time. So because of the speed of LLMs and the context that is already managed for you, a new developer can get the real-time documentations and personalized explanation, personalized onboarding. We have kind of a smart search, so if they're looking for any specific capability in the code base, they just write what they're looking for. It pops up what it is in the code base with the visualizer already explaining how it behaves. So I think it's becoming much more kind of a Q&A experience than here's a bunch of documents, go read them all.
Actually, this makes sense. But okay, I don't want to get back to this question about misconceptions and fears about. I can't help but think that in a few years we'll end up in a position where new developers just slap the keyboard. Like, I have no idea what I'm doing, like this meme with a dog, because you don't have to have deep understanding of the code, the tools, because you have this everything in the context. And in some cases, you don't even have to read that on the 100%, because the engine, the ACE, will pick up the context and will produce you the expected result, just as you described with the junior developer who on the next day already produced an ideal code for the company. Is there a fear here, or is this, or I know maybe we should just embrace the technology and relax? What's your opinion?
I think it's just a very natural evolution. Like, we already went through this phase a few times, just with coding over the decades, right? You're not thinking binary in any way, and we're jumping to languages that are more and more abstract. And I think this is just the next level of abstraction, right? Now we're at the point where we're writing code, and as we're writing code, we're thinking about how we implement it. But behind the scenes, the interesting thought process is, okay, well, architecturally and business logic, what do I mean for the code to do? And so LLMs just enable us to make that next jump of abstraction. So now the developer or the future developer will no longer need to think about the nuances of the actual code, and can think abstractly, okay, well, behavior-wise and logic-wise and architecture-wise, I want it to be this way. And now you do it, but I'm still going to be the engineer behind it that drives how I want it to act. And so I think we're becoming much more like proper engineers, moving to that level of abstraction.
Interesting. Because basically, we will have to focus more on different parts of our project, our responsibilities, and maybe even pay more attention to the detail that we didn't pay before because we were so busy producing code. And now we can delegate this part to the engine and focus on something else. Maybe, I don't know, for example, governance or guardrails or things like that, because I already saw a number of examples, because every time an agent posts a PR, it implicitly chooses dependencies. It alters data flows and basically shapes user experience, often without a line-by-line design documentation. And we already seen GitHub Copilot accidentally reproduce general public licenses strings in the codes, and I can imagine a future, some near future, where ACE injects, for example, a convenience analytics script that silently siphons health data to a third-party server, for example. And there are regulations like Europe's AI Act, and I can see how information security, they demand software build of materials exports before our code hits staging. And your documentation mentions multi-layer safety net, like syntax level linting, policy scans for forbidden licenses, things like that. And I just want to better understand is this the area we should focus more switch our attention from code itself to the way how we use it. Because, for example, if the tool chooses, if the engine chooses a tool for QR code generation or things like that, there are multiple vendors and each carries different phishing surfaces. And how does the agent weight those? And my question is there a way to enforce low risk defaults? And where is a human still think like, I don't know, like a red teamer, right? So should we have this person who will monitor these decisions and flag if something goes off? How do you think this should work now or in the future?
Sure. Yeah, I'll tell you how we approach it and what we do now, and also what I think is just generally right. So we mentioned kind of developers going from current stage to kind of higher level abstraction that lets them focus from the micro to the macro. So if the micro is like actual lines of code, to macro, like, okay, how does this work? How does it come together? So you mentioned the security, which is really important to us. That's why we built ACE in a way that just maps where the code is in your file system on your computer, because everything lives on a developer's machine, and we very intentionally built it that way. But the way we added guardrails to our agents is that they're just not allowed to make those sort of decisions. The way that comes into play is, and sometimes we have friction with users that they're like, hey, well, why doesn't it do that? And it's exactly because of this. But if it goes and it's given a task, and the task needs some sort of library that you have not configured, you haven't mentioned it in your package JSON. So in the list of libraries in your configurations for the project, you did not put that library. The agent can want to use it all day long, but we don't allow it to. It's not allowed to use anything not in your package JSON, not in your project configurations, and it's not allowed to add to your project configurations at all. In our perspective, this is a macro level responsibility that we leave to the developer, to the human. And we very explicitly say, okay, they ask us, well, why can't I just go and add this library if that's the right library it thinks we should use? And we say, that's a macro level decision. It has security implications. I need you, the developer, the lead engineer, choose what library you want to use there. You're probably going to have your own checks because of compliance and stuff that the agent can't, or it's not realistic for the agent to know. Do those checks, add it to the configurations. As soon as you said, okay, well, this library can be used in this project, the agent will gladly use it and will use it really correctly and properly. But that for us oversteps to where there's security concerns, and we're going to kind of put that responsibility on the human developers.
All right. So basically, there is still human work involved, and I'd say a lot of human work involved because I still think there is a certain level of responsibility that only human can take, especially when it comes to business, and you cannot rely on artificial intelligence here, even though it operates with a lot of data and a lot of opinions from different kind of industries, because you still have this particular case, your specific business, your users, so the case might be different, and you have to oversee the result before and not just blindly trust the outcome.
Yes, the way we think about it is that there's sort of decisions that you want your engineering leads to make, not your kind of junior developers. So we take the same approach. Anything that frankly as an organization you want your leads to make, the agent's gonna not make for you. You will need to make it. We're kind of enforcing the kind of a healthy delegation or kind of healthy responsibility across your organizational stack.
I know one safe, basically the safe decision that you can delegate to any artificial intelligence. Do not push to production on Friday evening, and just basically block this, and everybody will be happy. All right, I still have so many questions to you because this topic is very interesting, and we can speculate how it will work in the future, how new releases, how they will affect the way you work, and what's your expectation from the future. But I'd say we reserve this for the next time. But before we wrap up the conversation, I am sure a lot of our listeners, they would like to learn more about what you are doing. Is there a way for them to learn more about you, your projects, your job in the past and currently, where they can find you?
Yeah, absolutely. So first, I'd love to connect with everybody on LinkedIn. So please feel free to find me there. Just Tammuz Dubnov. You'll see AutonomyAI. And if you're curious about what we're doing and how it can be impactful for your organization, you're welcome to visit us at AutonomyAI.io. You can sign up there. We're already giving out early access. Just sign up. You get a call with Ian, our amazing director of customers. We'll onboard you. The beauty of kind of our approach is we don't need you to tell us anything. You just load the agent on your VS Code. It will read all the files, understand your standards, understand where the components live, and can just start working. And that's about it. Very easy to get started, just to sign up on our site. And of course, any questions, please reach out either there or on LinkedIn. Happy to connect.
Very fancy. Thank you, Tammuz. Thanks for coming. Thanks for sharing these insights with us. I think it was very interesting, at least for me. Those who listens to us, put your questions in the comments on YouTube or send us your emails while replying to our MKDev Dispatch newsletter every 2 weeks. And here, don't forget to subscribe because we have so many more upcoming on DevOps Accent. You don't want to miss. In 2 weeks, we will hear you again. Come and join us. Likes, subscribes. Thanks for coming. Thanks for listening. See you in 2 weeks. Bye.
Bye.
The cloud tech industry is evolving so fast. Do you keep up with it by improving your skills or upskilling your team? At MKDev, we offer a variety of workshops for just that, from the basics to expert knowledge. Before delivering our workshops and training sessions, we carry out a detailed assessment of each participant. To make sure the workshop is helpful for you and your team, we will add more content to it or throw out what you already know. Or we create a custom workshop specifically for the needs of your team and the specifics of your project.